Okay, class is being recorded. Anyone has any questions? Okay, let me find the day 2 first. That's day 1. Day 2 is here. Oh, I need to change the screen sharing. Day 2 is this one. All right. Okay, so good afternoon. Anyone has any questions regarding homework, regards the material we have been talking about? Okay, just feel free to stop me at any time. Okay, when you need to. So today we're gonna go to day 2 material. Textbook is 1.3, 1.5. So 1.3 talk about fractions, right? So what is a fraction? Fraction has a numerator, has a denominator. Right? So basically numerator is an integer, denominator is an integer. So like 1 over 2, 1/3, right? 3/5, so on and so forth. What about integer itself? Integer itself is also a fraction. The denominator is just 1, right? 1/2, what does 1/2 mean? So 1/2 means 1 apple shared by 2 people, right? Each one gets half of it. Right? That explains half. So 1 apple shared by 2 people, each gets a half of the apple. So usually a fraction is written as a over b, right? Or we can read as a divided by b, or a over b, or the quotient of a and b. Sometimes you hear this, the quotient of a and b. And the order is important. The quotient of a and b means a divided by b. If I see the quotient of b over a, that's b divided by a, right? So the division and subtraction order matters. And now, of course, what do we require in mathematics? The denominator cannot be 0, right? We don't define 1 over 0. It's like 1 apple shared by nobody. If 1 apple shared by nobody, we just don't care. We don't define that in mathematics. So B will never be 0. So it's not defined. It does not exist in mathematics. So A is called the numerator. B is called the denominator, okay? So whenever we see A over B, okay, A over B is A divided by B, or sometimes written as A slash B, all right? Or I can write this way. I can write A multiplied by, oops, sorry. A multiplied by 1 over B. So make sure we understand this. Or I can write it like this. A with parentheses. One over B. Okay, anyone has any questions? So make sure this makes sense for you, okay? It's important to understand this. So A divided by B, it's A divided by B. Or sometimes we write as this, A slash B, just for convenience, right? Because sometimes it's difficult to make A over B, so we just write as A slash B. Or, so what is the b here? This b here in the denominator is not b. A is A. A is in the numerator, A is A. But B is 1 over B. Okay, make sure whenever you see the number in the denominator, it's 1 over it, like I wrote here. It's A times 1 over B, because B is in the denominator. Okay, this is a very important idea. I see students make mistakes because of understanding of this part. Because A is in the numerator, so A can be on the top of B or can be written on the side, because A is a numerator. But the B will be forever in the denominator. Okay, so we can write as A times 1 over B. So sometimes we call the A over B is a quotient, right? A over B, of course, is a quotient. And when we multiply two numbers, we call the product of two numbers. So A divided by B or A over B, we call quotient, the quotient of A and B. Well, let's see this one. 9 divided by 3, right? 9 apples shared by 3 people. How many apples each one gets? Each one gets 3. Because 9 divided by 3, that's 3. Right? And I want to talk more about this. I can write it as 9 times 1 over 3. Divided by something is multiplied by its inverse. This is going to be 1. Okay. Or I can write it as 9 times, and write it inside parentheses. And write this way, okay? So we can write as 9 times 1 over 3. So 9 in the numerator can be written in the top or can be written on the side. And then this 3 looks like a 3, but because it's in the denominator, it's not 3, it's 1/3. Okay, if a number or an expression in the denominator, it always has 1 as numerator, so 1 over 3. Or we can write this way, 9 multiplied by 1/3, right? So this denominator is 1/3. It's not 3, all right? It's 1/3. Let's see the expression. Okay, so this one, numerator is x plus 2, denominator is 4 minus x. And we can write this way, x plus 2 divided by 4 minus x. We group them. You see, we use parentheses. We use parentheses to indicate they are together as one expression. We call this binomial, right? We have two terms, but it's a group. So a group of a group of two terms, so a binomial. So we have a binomial divided by a binomial. Sometimes I write as a slash, but more importantly, I want you to understand that's x plus 2 times 1 over . So we can write this way, right? If you want to put parentheses in the denominator, that's fine. All right, we can write this way. We can write the numerator on the side. So this indicates the, well, I can do this. I can do the parentheses, put the parentheses over there. Okay. So this one equals to this one. Super important. All right. Let's look at this one. You see in the denominator, we do not have 4 minus x. You know what? Let me rewrite this. Let me write this one. Let me use this better version. Oh no, this is not equal to this. So when we write it like a slash, if we do not put if we put a parenthesis, right, that indicates the denominator is 4 minus x. But without parenthesis, the denominator is only 4. Okay. Then minus x. You see the difference? If we don't write parentheses around the numerator, so that's also, that would be only 2 divided by 4. If we indicate the whole thing divided by, we have to put a parenthesis around. So this question, what is 9 divided by 1? Anything divided by 1 equals to anything, right? So think about what's 9 divided by 1. 9 apples shared by one person. How many apples this one gets? You know, this one gets them all. So anything divided by 1 is itself, right? So all integers have denominator of 1. Again, we're dealing with the variables. By default, a is 1a. A is raised by first power. A is a divided by 1. Right? Maybe I use a better version for this. Let's see. Right? Sorry, do the opposite. A divided by 1. So by default, okay, a is 1a, has a coefficient 1, has exponent 1, has a denominator 1. Okay, so everything is 1. So then we can add like terms, right? A plus 2a, that's 1a plus 2a, that's 3a. Well, a times a squared, that's a raised by first power, times a raised by second power, that's a raised by 1 plus 2, which means a raised by 3. So all those default ones. Let's say x plus 2 is the same as x plus 2 divided by 1. Okay. So this expression is the same as this divided by 1. Well, something divides itself is always 1, right? A divided by a is 1. A binomial divides itself is 1. The numerator and the denominator are the same, always 1, always, right? So something divides itself is always 1. Dividing by 0 is illegal, it's not defined, okay? It's not defined as illegal. It's not defined in mathematics or undefined. So we just don't deal with this situation in mathematics. Okay, 7 apples shared by nobody, and we don't care. So this does not exist in mathematics. Okay, denominator will never be 0. But 0 can be in the numerator. So 0 apples shared by 5 people. How many apples each one gets? Each one gets 0. Each one gets no apples. So numerator can be 0. 0 divided by -5, -0 was still 0. 0 divided by anything will be 0. Equivalent fractions, right? Like a half equals, we can multiply by 1. Okay, someone. Oh, okay. In that case, you can watch the recordings later, okay? Don't worry about it. You can watch the recordings later if you have difficulty now. We can always multiply by 1. So like a half, we can always multiply by 1. 1 is a transformer, right? You see how many 1 we get from here? You know, 1 equals this, 1 equals this, 1 equals this, 1 equals this, 1 equals this. So 1, I like to call 1 and 0 transformers, right? 1 is something divides itself. So we can multiply by 1, but this 1 is a 3 by 3. All right, 3 by 3. I should put this on the other side. Okay, so this one is 3 over 3. In this case, we get 3 times 1, we get 3. 3 times 2, we get 6. So 3 over 6 is equivalent to half, of course, right? And 50, we can multiply by 50 over 50. 50 over 100 is also half. So 3 over 6 is a half. 50 over 100 is half. So half is the simplest form. Half is the simplest form for 3 over 6, for 50 over 100. There are many more, the infinite many. So let's see this. Find a fraction equivalent to 2/3. So we start with 2/3. We multiply by 1. Right? And this one, we want it to be 2 over 2. Right? 2 over 2. Or you can make this one 3 over 3 or 4 over 4. Doesn't matter, right? As long as we find a one equivalence. But in this case, I choose 1 to be 2 over 2. So get 4 over 6. And you can choose 5 over 5. Then you get 10 over 15, so on and so forth. How many? Equivalent, infinite many, right? So let's see this one. Find a fraction equivalent to 3/8. Again, we multiply by 1, right? And this one is 4 over 4. Oh, this says with a denominator of 32. So so that means we don't know 12 yet, right? We know 3 over 8. Let me make a question mark first. Okay, because we want to make the denominator 32. The denominator 32. So from a to 32, what do we do to a to make 32? That's a times 4, right? That's a times 4. So that means we'll have to multiply 4 in the numerator as well. Right. So a times 4, 3 times 4. Well, you can just write as a, because 4 times a, that's 32. So we have to multiply by 4 with the numerator. 3 times 4, that's 12. So we got 12 over 32. Okay. So we're given the denominator to be 32. We need to figure out the equivalent fraction, the numerator of the equivalence. Okay, so many people have Wi-Fi trouble. Yeah, Dijon, for anyone, if you have trouble for Wi-Fi, make sure you watch the recordings later. Okay, every class will be recorded. Okay, anyone has any questions? Well, let's see this one. This one, we want to make the denominator to be AB, right? To AB. So from A to AB, we have to multiply by B. So we multiply B over B. So we get 3B over AB. Simplifying fractions, which means we want to find the simplest form, simplest equivalence, right? Let's see 45 over 18. 45, we can write as a 5 times 9. 18 can be written as 2 times 9. Well, now we see 9 over 9, okay? So this one equals to 5 over 2 times 9 over 9. Well, 9 over 9 is 1. Right? 5 over 2 times 1 is just 5 over 2. Well, let's simplify this. 3AB over 5B. Well, we see b over b, right? B over b is 1. So that's just left 3a over 5. The 9cd over 5bd, or d over d is 1. So that equals 9c over 5b. 9 times c plus d, 9 times a binomial. A 5b times a binomial, same binomial. So there's 9. So this one I want to do one more step. All right. Because there's a 1 there. See this. This is multiplication and division. I can write this way. Right? Multiply. I write like this. 9 multiply c plus d, 5b times c plus d. Now c plus d over c plus d, that's 1. So we just left with 9 over 5b. So that means when we have a common factor, you see the numerator, 9 multiplied by this binomial, denominator 5b multiplied. So the relationship is multiplication. Then we can cancel the same common terms. Let's see this one. We have a over b times c over d. All right. Which is a multiply numerator with a numerator, denominator with a denominator. So we get ac over bd. 4 over 3 times 2 over 7. 4 times 2, that's 8. 3 times 7, that's 21. Right. What if we do a fraction multiplied by an integer? Well, remember, integer can be in the numerator, right? Or we could think 35 is 35 over 1. 5 times 1 is 5. 4 times 35, right? It's 4 times 35. We could do 35, simplify with 5. 35 divided by 5, that's 7. So 4 times 7, that's 28. So when we do calculations, we're looking for common terms in the numerator and in the denominator to simplify them. Let's see this one. We have 4 over 5 times 5 over 4. Do you see those two are multiplicative inverse? Right. 4 over 5 and 5 over 4 are multiplicative inverse or multiplicative reciprocal. Because if we multiply numerator with numerator, we get 20. We multiply denominator with denominator, we also get 20. 20 over 20, that equals to 1. Right? When two numbers, we multiply, we get 1. And those two numbers are called reciprocals. 1 is called multiplicative identity. I think we talk about 0 is additive identity, right? A number subtract itself is 0. Or a number add its opposite additive inverse is 0. Well, let's see this one. We have negative term, negative 5a over 3b multiplied by 5 over c. When negative times positive, we just get negative. When numerator times the numerator, 5a times a, we can do 5 times 5, which is 25a. Denominator will have 3b times c. Well, that's just 3bc, right? Let's see these two. We just do numerator times numerator, right? Because this has two terms, a minus 6. So when we do that, we need to put a parenthesis around a minus 6 to indicate that this is a group. Then 3b times c plus 5 needs a parenthesis. We want to show c plus 5 is a group. Simplify completely. Let's see this one. We have 3b, a numerator. We can think 3b has a denominator of 1. And we have a fraction. Numerator is a minus b, denominator is 3b. Or because we have 3b multiplied by this fraction, because it's a multiplication, right? We can just multiply numerator with the numerator. We get 3b times a minus b. Well, we could think that 3b has a denominator of 1. 1 times 3b, that's 3b. Now we see common factor of 3b, right? 3b is a factor in the numerator, 3b is a factor in the denominator. Factor means the relationship is multiplication. Or you may see the relationship between a and 6 is not, right? It's subtraction. But we're treating them as a group. That's why I put a parenthesis here, right? So this is a binomial term. But however, this binomial is a factor of the numerator. So in the end, we'll get a minus 6. If anyone has any question, feel free to stop me at any time, okay? Otherwise, I just could keep moving along. Let's see this one. We have a fraction, negative 6 divided by b plus 4, multiplied by b plus 4. Now we recognize the relationship is a multiplication. We have negative times positive. We must get a negative value. And then we see this b plus 4, no, this b plus 4 binomial is a numerator. This b plus 4 is in the denominator. So those two are common factors. Okay, so how? You have a question? So how you raise your hand? Do you have a question? I know your signal, probably this is by accident. Okay, his signal is not so good. So b plus 4 numerator, b, then we see 1 over b plus 4, right? Because b plus 4 in the denominator, that's 1 over b plus 4. So that means we just get a negative 6. Let's see this one. If we have fraction division, the quotient of two fractions, a over b divided by c over d. So what do? Remember I said before, 10 divided by 2 is the same as 10 multiplied by half. 10 divided by 2 is 5. 10 multiplied by half is also 5, right? So division is a multiplication of the inverse. So what is the inverse? What's the reciprocal or inverse of c over d? That's d over c, right? We change division into multiplication. We take the multiplicative inverse of c over d, which is d over c. Then we multiply. Numerator with the numerator, we get AD. Denominator with the denominator, we get a BC. Anyone has any questions? Kiana, you have a question?
So when it's division, we're changing it to multiplication and we're switching the denominator and the denominator and the numerator?
Yes.
Okay.
If you divide one fraction divided the second fraction, you change the division into multiplication. You switch the numerator and denominator of the second term. C over D becomes D over C.
Okay. Thank you.
Okay. You're welcome. But the A over B, we don't change. The first one doesn't change. The first one stays the same. So the idea is here. The idea, let's see here. 10 divided by 2, that's 5. 10 multiplied by half, right? So when 10 divided by 2, the 2 appears in the denominator, that's half. That's 10 times half equals 5. 2 and a half are multiplicative inverse, all right? Let's see this example. Well, 5 over 2, we have
I'm
2
sorry
over
to
5.
cut you off, Professor, but it's only for division we flip it around, right?
Only for division.
Okay, thank you.
You're welcome. Let's see this one, this division. So 2 over 5 divided by 3 over 4. We change it to be 2 over 5. 2 over 5 don't change. We change the division into multiplication. Then we change 3 over 4 to be 4 over 3. Then we multiply. We multiply 2 with 4, we get 8. We multiply 5 with 3, we get 15. Let's see this one. We have negative 1 fraction, negative fraction. Well, negative divided by negative, positive. So we can forget about the negative sign. 1 over 6 stays the same. And we change division into multiplication. We flip 3 over 5 to 5 over 3. Now 1 times 5 is 5, 3 times 6, that's 18. Let's see this one. We have 2 over z divided by 3 over 4. We change to be 2 over z multiplied by 4 over 3. With 3 over 4, change to be 4 over 3. Then we multiply numerator with the numerator, we get an 8. Denominator with the denominator, we get 3z. Well, let's see with the symbols, with the letters. So let's see this one. Y divided by y over 8. We do y multiplied by a over y. Right? Numerator and denominator will switch. And y over y, this y is the numerator, this y is the denominator. So that's y over y is 1. So we just get an 8. Right. Let's see this one. Negative AB over 2z divided by 3 over 4. Well, negative time divided by positive will stay to be negative. So we're going to keep this negative sign. AB over 2z, we keep it. We change division to be multiplication. We flip 3 over 4 to be 4 over 3. Then we multiply numerator with numerator, we get 4ab. Denominator with denominator, 2z times 3, this is 6z. Okay. Then we see common factor between 4 and 6, that's 2. So we divide by 2 in the numerator and in the denominator. So our final answer is this, negative 2ab over 3z. Now, binomial. We have binomial term now. So the numerator of this one is x minus 4, 2 terms, we call binomial, divided by z. Then divided by the second term also, denominator is a binomial over 7. So first we change the division into multiplication, then we flip the second one, flip numerator to denominator, denominator to numerator. Now do we see x minus 4 in the numerator, x minus 4 in the denominator, and the relationship of the multiplication? That means if we want, we can rearrange this. Let me just do one more step to convince you. So we can rearrange this because it's multiplication. What's special about multiplication? Commutative, right? Which means we can switch the order. The 7 times x minus 4, right, can be written as this. Z times x minus 4 can be written as this. So we see we have x minus 4 over x minus 4, which is 1. So in the end, you'll get 7 over z. All right, sometimes we need this common denominator. Let's see this one. We want to add 2 fractions. If we want to add 2 fractions, we need a common denominator, which means the 2 fractions need to have the same denominator. In this case, the denominators are the same, just b. So it says if the denominators are the same, which is inherit the denominator, then add the numerators, so a plus c. So the answer is a plus c divided by b. Let's see some numbers. 2 over 7 plus 3 over 7. Well, that's 2 plus 3, that's 5. 5 over 7. The denominator does not change when it's addition. 2 over a plus 3 over a. Well, that's 5 over 8. Negative 7 over 2m minus 3 over 2m. Well, denominator is 2m. So we just perform the operation with the numerators. We get negative 7 minus 3. But negative 7 minus 3, which is minus 10. Minus 10 divided by 2, which is just 5. Right? So this can be simplified as negative 5 over m. Because it's a common factor of 2. The negative sign can be written in the numerator, can be written in the denominator, or can be written on the side. Okay, 3 places it indicates. All indicates the term is a negative one, is a negative term. add and subtract fractions with different denominators. Well, let's see, these are different denominators. 2 over 7 plus 3 over 4. What's the common denominator? The common denominator is 7 times 4. Why? Because 7 is a prime number, right? So the common denominator is 7 times 4, because 7 is prime number. So for 2 over 7, we multiply by 1, but this one is 4 over 4. Why can't I change the color? Right? This one is 4 over 4. Can I make it bigger either? And 3 over 4, we multiply by 1 also, but this one is 7 over 7. Then we do the multiplication. 2 times 4, that's 8. 4 times 7, that's 28. So 2 over 7 now becomes 8 over 28. Same way, we change 3 over 4 to its equivalent fraction of 21 over 28. Now we see these two fractions have a common denominator. So we just add the numerator. 8 plus 21, that's 29. So we get 29 over 28 in the end. A question, you can just speak up.
Okay, Professor, can you hear me?
Yes, I can hear you.
Thank you. So one question I have is, if you're adding and you need to get, like in this example, a common denominator, do you only multiply to the lowest amount that they both would share?
Yes, that's called the least common denominator. But for this, in this case, you see 7 is a prime number. So we just multiply the two numbers. But sometimes, maybe later on, we will have examples. We will have examples. Maybe we find the least common denominator. Maybe let me just make one. I know what you're talking about.
Okay, thank you.
You're welcome. Let me just make an example. That's a good question. Let's see, I have two. So this is a first example. This is a second example. I have a 2 over, not 7. Maybe I change this one too. I change this one to be 1 over 6. All right. I change this one to be 1 over 6 plus 3 over 4. So I could multiply 6 with 4. I get 24. That's fine. But usually we want to find the least common multiple, which means the number divides 6 evenly, divides 4 evenly. So which is 12, right? So we want to change 1 over 6 to be 2 over 12. We want to change 3 over 4 to be 9 over 12. Oops. Minus 9. 9 over 12. Right? Basically, I multiply 1 over 6 with 2 over 2. I multiply 3 over 4 with 3 over 3. So I get 2 over 12 plus 9 over 12. I don't have to go to 24, you see this, right? But it's fine to go with 24. Right? If the numbers are small, we don't need to find the least common denominator. That's called the least common denominator. So let me write on the side. So then this one equals to what? Right. 2 plus 9, 11. Denominator stays to be 12. So we call it least common denominator, or sometimes called the least common multiple, all right, of 6 and 4 equals to 12. Let's see the negative sign. Negative sign can be in the numerator, negative sign can be in the denominator, negative sign can be up front. So that all mean the same thing. But usually we keep the negative sign up front. But when we do calculations, we can move to the numerator or we can move to the denominator. Okay, it depends on what we need. Negative 2 over 3 is 2 over negative 3 is negative of 2 over 3. So let's see evaluations. So we want to evaluate x squared when x equals to 3 over 2, right? So in that case, x squared is a 3 over 2 squared. So that's just 3 over 2 times itself. What is 3 times 3? 3 squared is 9. 2 squared is 4. So that's 9 over 4. Well, this one is a little bit complicated. So this one is negative 3x squared plus 2x. Now we want to calculate x equals to 1/3 and x equals to negative 1/3. Well, first let's see x equals to 1/3. We just plug in. So we get negative 3, well, negative 1/3, positive 1/3 of square plus 2 times 1/3. Again, 1/3 squared, that's 1 over 9, because 1 squared is 1, 3 squared is 9. Then 2 times 1/3, that's 2 over 3. Right? Negative 3 times 1 over 9, that's negative 3 over 9. Plus 2 over 9, that's just negative. Oh, we can change it 3. We need a common denominator. So 3 over 9 equivalence is 1/3. Negative 1/3 plus 2 over 3. We have a common denominator 3. So we just add the numerator. So now we move this negative sign to the numerator. Right? Because the denominator is just positive 3. So we get a negative 1 plus 2. Right? Negative 1 plus 2 is just 1. So in the end you get 1/3. Just evaluation, right? Just plug in the value for the variable. Well, let's say negative 1/3. Negative 1/3 squared is the same as 1/3. So the first term it would be the same, negative 3 over 9 or negative 1/3. Well, the second one is 2 times negative 1/3. Well, 2 is positive. Positive times negative, that stays to be negative. So we get negative 2 over 3. Negative 2 over 3. Then now we have common denominator. We can perform the operation regards to the numerator. So we move the negative sign to the numerator, right? So negative 1/3, the numerator is negative 1. Negative 2/3, the numerator is negative 1. Negative 1 plus negative 2, that's negative 3. Negative 3 over 3, that's negative 1. So that's evaluation. We just plug in a given number in the place of the variable. Okay, so that's about the calculations of fractions. Now let's see properties of real numbers. First, let's remember what is a real number. How is a real number defined? Doesn't say here. So let's understand the word real numbers. Real number means when you square a number, it cannot be negative, right? It has to be greater than or equal to 0, which means at least 0. When you square a number, or when you multiply a number by itself, right? It cannot be negative. So that's a real number. That's the definition of a real number. So let's see commutative and associative property. Right? Commutative, let's say do plus and multiplication. When we do plus 3 plus 5, that equals to 5 plus 3. Right? We can change the order. 3 times 5, that's the same as 5 times 3, which is 15. A plus B is the same as B plus A. A times B is the same as B times A. So with multiplication and addition, so addition, multiplication are commutative. Commutative means the order doesn't change anything. But with subtraction and division, they are not commutative, right? 6 minus 5 equals 1. 5 minus 6 does not equal to 5 minus 6, because 5 minus 6 is negative 1. You see, if we change the order of those numbers, the result change. Same thing for division. Divided by 3, does not equal to 3 divided by 5. A divided by B doesn't have to equal to B over A. Right? A minus B doesn't equal to B minus A in general. For some special cases, maybe. Associative property, right? If we have 2 plus 3 plus 4, we can group either two of them. We can calculate the 2 plus 3 first. 2 plus 3 is 5, 5 plus 4, 9. Or we can plus 3 and 4 first. 3 plus 4, 7, 7 plus 2, 9. Right? So they're both equals to 9. In general, we have A plus B plus C. You know, we can't add any two numbers first because they're commutative, because they're associative. Same thing with multiplication. We have 2 times 3 times 4. You know, we can multiply any two first. We can multiply A, B, C. We can multiply any two first. The result will be the same. So addition and multiplication are associative. So they're very nice operations. Addition and multiplication. They're commutative and they're associative. But division is not. Subtraction is not. Right? Oh, hold on, subtraction. Actually, subtraction is. Because subtraction is adding negative numbers. Just division is not. Right? Let's do, hold on a second. Yeah. Let's do 2 minus 3 minus 5. Okay. 2 minus 3 is -1. -1 minus 5, that's -6. Okay. Or I can group the other two. I can do 2 minus 3 minus 5, right? If I do these two first, I get 2 minus, oh, you see, this is different. So this one I should put not associative. Division is not division, and subtraction are not associative. Okay. So that's for division. Let's do one subtraction. So if I do those two first, right? Even what if if I do those two first, I get -1 minus 5, which is -6. But if I group those two first, right? You see, subtract 3 minus 5. That makes a difference, right? That becomes 2 minus -2. Becomes 4. Right? Of course, -6 does not equal to 4. So in general, division and subtraction are not associative. Identity properties. So 0 is called additive identity. Okay. Additive identity means A plus -A equals to 0. All right. And then we call A and negative A are additive inverse. A and negative A are additive inverse. Identity property for multiplication. So 1 is called multiplicative identity. Because 1 times A will be 8. 1 times anything will be anything. Additive inverse property. Oh, okay. I talked this about already. 2 plus -2 equals 0. 2 and -2 are additive inverse with each other. Okay. A plus negative A is 0, negative A plus A is 0. Well, what about with multiplication? Multiplicative inverse, or we call reciprocal. I have problem to pronounce this one. Reciprocal. It's not Spanish. The reciprocal of A over B is B over A. Just flip the numerator and denominator, right? But then we require B cannot be 0, A cannot be 0. Because A over B times B over A equals 1, equals the multiplicative identity. So any two numbers multiplied to be 1, they are called a multiplicative inverse or reciprocal. Let's see some examples. 2.5, reciprocals. 3 1/3, reciprocals. 2 over 3 and 3 over 2. 4 over 7 and 7 over 4, so on and so forth, right? You just flip the numerator and denominator, it become its multiplicative reciprocal. Distributive property. Right? If we have A times the binomial, we can distribute A to the binomial. So that's AB plus AC. You have B plus C times A. We can also distribute A into BC. So we got BA plus CA. Right? With the minus, the same thing. So this is negative A. We distribute negative A to B. That's negative AB. We distribute negative A to negative C. Negative times negative become positive. So we get positive AC. B minus C times A. Same thing. We get BA minus CA. So we have this negative B minus C times A. So first we can multiply, we can distribute the negative sign inside the parentheses. So that becomes negative 1 times B, which is negative B, negative times negative 1C, which is positive C. Okay. Then we have this, we want to distribute this A. A times negative B, that's negative BA. A times C, this is CA. Any questions? Okay. So the numbers you may look through yourself, okay, the same way. Let's see this. So let's recognize this one. Let me make this bigger. We have a monomial, one term, multiplied by a binomial, B plus C. So B plus C is a binomial, right? And this whole thing is a product. It's not addition. Because addition is inside this group. So this is a product. So this product has two factors. Okay, two factors. Remember last class we talked about factors. The factors are A and AB. Right? A is a factor and B plus C is a factor. So two factors. So even it's binomial, but we're treating it as a group. So in this case, A times B plus C is a product, and this product has two factors. A is a factor, and B plus C is also a factor. Let's see this one. AB plus AC is a sum. Right? AB minus AC is a difference. Of course, right? So let's see this one. We want to expand this, then simplify it. So we have 5 multiplied by a binomial. So what do? Let's just do 5 times each one, right? 5 times 3x over 5, we see 5 divided by 5, or 5 times 1 over 5, that becomes 1. So we just get 3x. 5 times negative 1, that's just negative 5. Anyone has any questions? Okay, let's keep going. Let's see this one. 10 times 3x over 5 minus x over 2. So we distribute 10 into the two terms. So we do 10 times the first term minus 10 times the second term. Well, we see 10 in the numerator. This 5 is 1 over 5 in the denominator, right? So we think as 10 divided by 5, which is 2, right? Which is 2. Or if we have a problem to do that, we can think this way. It's 10 times 3x in the numerator, so we can switch the position to 3x times 10. Then we say 10 divided by 5, right? Similarly, for the second one, we say 10 divided by 2. Well, 10 divided by 5 is 2. 2 times 3x is 6x. Then the second term, 10 divided by 2, is 5, which is 5x. 6x minus 5x, which is 1x. We don't bother to write a 1, we just write x. This is C. 100 times 0.3x plus 0.25. Well, 100 times 0.3 is just 30, right? Because ignore the points, just do 3 times 300, 100, that becomes 300. Then you add the 1 point into it. So we get 30x. Then 100 times 0.25, that's 25. Negative sign in front of a parenthesis, we can distribute to -1. All right, we think as a -1. -1 times t, that's -1t, which is write down as a -t. -1 times -6 become +6. So in the end, we have -t plus 6, or we write as 6 minus t. Let's see E. Well, E is a little bit complicated. How many terms do we have? We have 3 terms. We have A as one term, red color. We have -4 times 2 minus 3x, parentheses, blue color, second term. The third term is -3 times x plus 1. All right. We have 3 terms. So what do? We distribute -4 into 2 into -3x. So -4 times 2, that's -8. -4 times -3x become positive 12x. -3 times x, -3x. -3 times 1, that becomes -3. Now we can combine like terms. 12x minus 3x, that's 9x. Well, a minus a is 0, then we have -3 here. So that becomes 9x minus 3. Anyone has any questions? So distinguish terms, how many terms, right? Distribute the coefficient, the common factor. Let's say F. F will have 2 terms, right? 4 times x minus a is one term. A negative of x plus 3 is second term. So we distribute 4, we get 4x minus 32. We distribute -1 into the second one, so we get -x minus 3. So combine like terms, we get 3x minus 35. Anyone has any questions? Pretty simple, right? Anyone has any questions? Kiana, any questions? Or Aisha? If you have any questions, just speak up. Any questions? Okay, we have 36 of us, 35 students, so some people are not able to make it. 31, 31, 31, 31, oh, this one, 29. Chapman Chantel. Oops, no.
I have a question about the homework.
Okay.
We only have homework on the days that we have class, right? Because that's what I see on the thing, on the calendar.
Let me see. Let me share my screen with
Okay.
you. Because everything is done by the department chair. I have no idea about it. Let's see my open math. Oh, I haven't opened yet. Okay, that's our class. Yeah, this calendar shows you due dates of the homework. No class, very nice. Where's the due dates? Well, I guess the due dates only show on the calendar then. I don't see here. It shows on the calendar.
Yeah, thank you.
Yeah, you're welcome. Make sure you check the calendar. All right, any other questions? That's the material I want to talk about today. Fractions, evaluation, and the properties of real numbers. If you have no questions, you can go ahead to do your homework. Yeah, attendance is automatically because on the grade center, it shows me who is there, who's in class. It's not automatically. I have to do by hand later. But the system tells me who's here. All right, so that's all for today. If anyone has a question, want to talk to me, I'm here. Okay, if you don't have a question, just go ahead to do your homework.
Thank you.
You're welcome. Thank you. Have a good night.
Thank you for the class today.
You too.